Have you ever stopped to ponder why water, of all the substances on Earth, expands when it freezes? This simple question opens up a world of intrigue and complexity. Water, the life-giving liquid we take for granted, holds a myriad of mysteries. It defies the norm, expanding instead of contracting when it turns to ice. It's a unique trait, a quirk of physics that sets it apart from most other substances. So what makes water so special? Join us as we dive deep into the fascinating physics of water. Water, a simple molecule with 2 hydrogen atoms and an oxygen atom, holds secrets that baffle even the brightest minds. Let's dive in. Picture a water molecule as a tiny Mickey Mouse head. The oxygen atom forms the face, while the 2 hydrogen atoms are the ears. This molecule, known as H2O, is not symmetrical. Instead, it's bent, with the hydrogen atoms leaning towards one another, forming an angle of about 104.5 degrees. Now, this is where the magic happens. Because of this peculiar structure, water molecules develop a slight charge, making them polar. The oxygen atom, being more electrifying than the humble hydrogen, pulls the shared electrons closer to itself, giving it a slight negative charge. The hydrogen atoms, in turn, carry a slight positive charge. These charges enable water molecules to stick together through what we call hydrogen bonds. Picture water molecules as tiny magnets, attracted to each other, building a network of interconnected molecules. This bonding is the secret behind water's unique properties. For instance, these bonds give water a high boiling point compared to other similar molecules. They also make water a great solvent, able to dissolve a wide range of substances. Furthermore, they allow water to absorb a large amount of heat, making our planet's climate more stable. The unique structure and hydrogen bonding in water are responsible for its distinctive properties. One of the most intriguing properties of water is its ability to expand when it freezes, a phenomenon known as the ice paradox. Now let's dive into the details. This paradox is all about the structure of ice. You see, water is made up of H2O molecules, each molecule consisting of 1 oxygen atom and 2 hydrogen atoms. In liquid form, these molecules are free to move around and are relatively close to each other. But as the temperature drops and water begins to freeze, something peculiar happens. The molecules slow down and they start to arrange themselves in a hexagonal pattern, similar to a honeycomb. This pattern is less dense than the disordered, more tightly packed structure of liquid water. As a result, ice takes up more space than the same amount of liquid water, causing it to expand. The ice paradox is a perfect example of how the microscopic structure of water can lead to macroscopic effects. But the mysteries of water do not end with the ice paradox. We must dive deeper into the physical properties of water to truly appreciate its marvels. Let's consider water's high specific heat capacity, which is the amount of heat needed to increase its temperature. This trait allows our oceans to absorb vast amounts of heat without significantly warming up, acting as a global temperature regulator. Now let's move on to water's claim to fame as a universal solvent. This title isn't just for show. Water's polarity allows it to dissolve more substances than any other liquid. This is why water is vital in biological systems, as it helps in transporting nutrients within organisms. And let's not forget about water's surface tension. This property allows small creatures to walk on water and droplets to form, demonstrating the intricate balance of cohesion and adhesion. These properties make water not just essential for life, but also incredibly fascinating to study. In just a few minutes, we've explored the complex and captivating world of water and its physics. We've peered into the unique structure of water, a molecule that forms an angle, creating a polarity that allows for the formation of hydrogen bonds. These bonds are the unseen threads that tie water molecules together, granting water its high boiling point and ability to remain liquid under a wide range of conditions. We've also grappled with the ice paradox, where water, unlike most substances, expands as it freezes. This anomaly leads to ice floating on water, a phenomenon essential for aquatic life during winter months. And let's not forget the other physical properties of water that we've discussed: its high heat capacity, surface tension, and the ability to dissolve a wide range of substances, making it the universal solvent. Water, as we've seen, is far more than just H2O. It's a substance that continues to intrigue, surprise, and sustain us.